Refraction of light when it travels from denser medium to rarer medium. When a ray of light travels from denser medium to rarer medium, again the same diagrammatic representation we are going to consider, that is PQ is the interface, AB is the incident ray, BC is the reflected ray, N dash will be the normal. But the condition here changes is when the ray of light travels from denser medium to rarer medium, the reflected ray always bends away from the normal. You can see here completely the reflected ray where it is bending away from the normal, that is N dash. And the condition we are going to give here is, since R is greater than I, that is angle of reflection is greater than angle of incidence. So deviation, which is represented by the Greek letter dou, is equal to R minus I. The angle between the incident ray and normal is called angle of incidence, which is denoted by small letter I, and the angle between refracted ray and the normal is called angle of refraction, which is denoted by small letter R. The angle between direction of incident ray and the direction of refracted ray is called the angle of deviation, which is denoted by the letter dou. Here the questions will be asked as, what is angle of incidence for 1 mark, or what is angle of refraction, or what is angle of deviation. These three questions carry 1 mark each. Or for 1 mark also, what happens when a ray of light travels from denser medium to rarer medium. This will also be asked for 1 mark. Another question which arises here, what happens when a ray of light travels from rarer medium to denser medium? Most of the questions can be asked for 1 mark each here. Another one is, what is refraction of light? Or if it is asked for 2 marks, what is refraction? Show the diagrammatic representation of refraction of light. Means you have to write the definition of refraction, which carries 1 mark, and also you have to draw the diagrammatic representation, which we have explained in the starting of the video. Next topic is laws of refraction. The phenomena of refraction of light was experimentally studied by Snell, W. Snell, a Dutch professor. He concluded that the refraction of light takes place according to the following 3 rules, and they are known as laws of refraction. So in your 10th standard, you have already studied about the light chapter, starting with the refraction and the laws of refraction. The same will be repeated here. First law states that the incident ray, refracted ray, and the normal drawn at the interface of media all lie in the same plane. Second law states that Snell's law also, it is called as the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media for a light of given wavelength. This second law of refraction, it is called as Snell's law. It is represented as sine I by sine R. The ratio of sine of angle of incidence, that is sine I. Sine I, sine of angle of incidence to the sine of angle of refraction. It is equal to a constant. Okay. So this constant is called as refractive index of a medium 2 with respect to medium 1, which is denoted by N21. N21 means the refractive index of medium 2 with respect to medium 1. Suppose angle of incidence is greater than angle of refraction, then N21 is always greater than 1. If in that case the ray always bends towards the normal. Suppose angle of incidence is less than angle of refraction, then N21 is less than 1. The ray always bends away from the normal. A ray that falls normally on the interface does not undergo refraction, and Snell's law is not applicable for normal incidence. This is one of the exception we can say. Third law, during refraction, frequency of the light does not change, whereas the wavelength and speed of the light changes. This is the third law you can say of refraction. One more thing, when the light undergoes refraction, its velocity and wavelength changes, but frequency does not change. This happens due to the change in the media. As I already told, for the refraction to occur, there is the necessity of two different media. That is why the velocity also changes and the wavelength of the light also changes, but the frequency